The fifth lecture video on temperature and heat will cover specific heat. To motivate our discussion on specific heat, imagine a piece of steel and a pot of water outside on a sunny summer day. What happens to each substance? Well, the steel gets very hot, but the water only warms a little bit. It won't start boiling or scald you. Why does this happen? Well, water has a greater capacity to absorb heat and energy, whereas steel cannot absorb as much heat. This is one reason why water is so useful in cooling applications like power plants. Water can absorb a lot of heat without its temperature changing very much, unlike steel, whose temperature changes quite a bit. The specific heat of a substance is a measure of the substance's capacity to absorb or give off heat per degree change in temperature. The specific heat is the amount of heat necessary to change the temperature of 1 kilogram of at 1 degree Celsius. If we are looking at specific heat in the English system, the specific heat is going to be the amount of heat energy needed to change the temperature of 1 pound of it 1 degree Fahrenheit. The specific heat of materials can be found in a table or on the internet. Let's look at the specific heat formula, or the formula to find the amount of heat added or taken away from a substance to produce a certain change in temperature. If we have metric units, Q equals M times C times delta T, but if we have English units, Q equals W times C times delta T. Q is the heat, C is the specific heat, which can be found on a table, M is the mass, W is the weight, and delta T is the change in temperature. If we are looking to calculate the specific heat in metric units, this would be C equals Q divided by M times delta T. But if we had English units, C equals Q divided by W times delta T. Make sure you use parentheses in the denominator in both of these equations to find the specific heat. Now we will look at a couple of examples calculating heat using different units. How many kilocalories of heat must be added to 20.0 kilograms of aluminum to raise its temperature 125 degrees Celsius? First, we will write down the information we are given. We know the mass is 20.0 kilograms. We also know that we have aluminum, so we need to use a table of specific heats to find the specific heat of aluminum. The trick is to make sure we write down the correct units, since there are a couple of different options. Since we have mass in kilograms and the temperature in degrees Celsius, we will use the unit of kilocalories per kilogram degrees Celsius. The specific heat of aluminum is 0.220 kilocalories per kilogram degrees Celsius. The change in temperature is going to be how much we want to raise the temperature, which is 125 degrees Celsius. In this problem, we are trying to find Q, the amount of heat needed. The basic equation we can use to calculate heat is that Q equals M times C times delta T. Next, we can substitute and see that Q equals 20.0 kilograms times 0.220 kilocalories per kilogram degrees Celsius times 125 degrees Celsius. This gives us 550 kilocalories of heat that must be added to the aluminum. Let's look at one more example, this time with some different units. How many joules of heat must be absorbed to cool 15.0 kilograms of water from 100.0 degrees Celsius to 50.0 degrees Celsius? We can go ahead and write down all of the data we were given. First, we know the mass is 15.0 kilograms. Since we have mass in kilograms and we want heat in joules, our specific heat must have units of joules per kilogram degrees Celsius. Therefore, the specific heat of water is 4,190 joules per kilogram degrees Celsius. The change in temperature we are looking at is 100.0 degrees minus 50.0 degrees, which gives us a change in temperature of 50.0 degrees Celsius. We are trying to find the amount of heat, Q. Now that we have everything recorded, we can write down the basic equation for heat. Q equals M times C times delta T. Next, we can substitute into our basic equation. So Q equals 15.0 kilograms times 4,190 joules per kilogram degrees Celsius times 50.0 degrees Celsius. This gives us 3.14 times 10 to the 6 joules of heat, or 3.14 megajoules. This concludes our discussion on heat energy and specific heat.